So let's continue. Let's see question number 16. Okay. So for this question, we'll have to do something called rationalization. Alright, have you heard of rationalization? In class 9 we studied. So in rationalization, what do? We have 1 minus sine A upon 1 plus sine A. So what do we multiply by in rationalization? Do you remember? You have to focus on the denominator. Alright. So you have to multiply with the same denominator but with opposite sign. So if you have plus, you multiply by minus. So here also you have to multiply by minus. These two will remain same and this will depend on the sign of this. Now, does this look anything familiar that we have done? Have we done questions like this before? Yes, but if you remember, in those questions we multiplied by the same sign, right? We did not rationalize. So why are we rationalizing here? One of the reasons why are we rationalizing here, because on the right hand side you see we don't have any denominator. Okay, if you don't have any denominator on the right hand side, it is this method. You have to multiply with the opposite sign. Okay, now let's see what do we get here. So 1 plus sine into 1 minus sine into 1 minus sine. So it will be 1 minus sine whole thing square. Yeah, when the signs are same, whole thing square. Here the signs are opposite. 1 plus sine, 1 minus sine. So it will become a square minus b square. Then let's keep the numerator as it is. Denominator, do you see anything? 1 minus sine square is what? One minus sine square is right. Cos square a. Now we will take the square under one bracket. So we get 1 minus sine a divided by cos a. Alright. Then we do something called splitting the numerator. So we're going to split the numerator as shown. Okay. Splitting the numerator is basically reverse of LCM. So if you take LCM here, you end up back here. Alright, now why are we splitting the numerator? Because 1 minus cos is nothing but sec A and sine minus cos is tan A, whole thing squared. And that is the right hand side. So let's see question number 19. So in question number 19, you look at the left hand side. Okay, what do you think we can do on the left hand side? How can we simplify left hand side?
We take sine and numerator and cos and denominator as common.
Yes, very good. We can see that numerator has two terms, sine theta and sine cube theta. So we can take sine theta common. So I can write this as sine theta. If I take common, then from here we are left with 1. From here we're left with 2. And since from cube 1 sine theta is gone, so you'll be left with sine square theta. Similarly, from the denominator I can take cos theta common. And from this we're left with 2 cos square theta minus 1. Alright. Now if you see sine theta by cos theta is nothing but tan theta, and this is something that is extra. Alright, because see, right hand side is just tan theta, which is something that we already got, right? So this somehow needs to be cancelled. Okay, take your time. And what do you think we should do here? See, can I cancel them right now? No, because they're different. So if you want to cancel, they should be
Like
alike, right? They should be same. So how can I make them same? What do you suggest? See, if we want to cancel, they must be same, right? So how can we make them same? Let's leave the numerator as it is. So 1 minus 2 sine square theta. Denominator, this cos square I can convert it to sine square, but 2 will be inside the bracket and cos square will be 1 minus sine square theta minus 1. Okay, so just this cos square I'm converting to 1 minus sine square. So that's what you can do if there is 2 in front. Alright, so if you open this bracket now, what do you get? This I'll not touch because I already have that on the right hand side. This one let's manipulate. So 1 minus 2 sine square theta. Here if I open the bracket, 2 ones are 2 minus 2 sine square theta and minus 1. So then we will have tan theta, and this is 1 minus 2 sine square theta. 2 minus 1 is 1. So 1 minus 2 sine square theta. Then we can cancel this whole thing and this whole thing because they are alike. So you're left with just tan theta, which is the right hand side, proved. So in question number 20, what do you think we should do? What we can do here is we will do rationalization again. Okay, so let's try to rationalize cos A divided by 1 minus sine A. Now, if you rationalize, you get 1 plus sine A upon 1 plus sine A. Rationalization means the sign should be opposite. Okay. After that, A minus B, A plus B. So you end up with A square minus B square. And here this will be cos A into 1 plus sine A. Then we get cos A 1 plus sine A. This is the formula. 1 minus sine square is cos square A. Then we can cancel square and cos. Then you're left with 1 plus sine A divided by cos A. Then here if you split the numerator, you get 1 minus cos A plus sine A by cos A. 1 by cos is sec A, sine by cos is tan A. Now generally when do we rationalize? No, generally we rationalize when the left hand side has a denominator and right hand side does not have a denominator. See, here we have a denominator, but here we don't have a denominator. Okay, let's put that as a third trick for now. Okay, let's see if any question does not follow that. Okay, so basically the next question is exactly the same. 21, left hand side has a denominator, right hand side does not have. So just try the same trick for 21. That means rationalize question number 21. Alright, so I have seen what mistakes you are making. In this explanation, I'll incorporate those mistakes as well. Alright, so how do you do this? We need to rationalize this, right? Why are we rationalizing? We are following the third rule. If the left hand side has the denominator, but right hand side does not have a denominator, that time we will rationalize. So how do you rationalize? Sin A tan A 1 minus cos A multiplied by, so rationalization means the sign should be opposite. So 1 plus cos A into 1 plus cos A. Now look at the denominator, that's more important. Denominator, what do we have? A minus B, A plus B. So it will be like A square, which is 1 square is 1, minus B square. B is cos, so cos square A. Numerator, we will not expand and we will leave it as it is, plus cos A. Till here, I think it should be fine, right? Now, 1 minus cos square is what? Sine square. So we can write sine square A. This will become sine A, and this tan, I'll just convert it to sine A upon cos A multiplied by 1 plus cos A. So what most of you are writing is, you're just writing the terms randomly. You're not supposed to do that. You notice how I'm writing everything. First I write equal to, then I draw this main division first, right? I write the main division beside the equal to, then if I'm substituting a term for the another, then I'm doing that. Okay, so first draw the main division, after that you can write whatever conversions you're doing. Okay, so now Here we can cancel sine A and square, and then we can cancel this sine A with the entire square. So now the main division, there's nothing below it, so we don't need to write. So here what do we get? 1 upon cos A times 1 plus cos A. Okay, so now you open the bracket. 1 by cos into cos. So if you don't know directly, then you can write down one more step into cos A. This into this. I'm just showing the steps. Then 1 by cos is sec. And here we can cancel cos A and we end up with 1. So that is right hand side. Question number 25. What do you suggest I do for question number 25? LCM. We can take LCM also. Yeah, we can do it with LCM also. Actually, there are many ways to do it, okay? But I'll just try to stick to the tricks that I'm using. Okay, we can LCM. You can try with LCM. I heard someone said rationalization. Okay, we will rationalize. We can rationalize also. I'll go with rationalization. So what I'll do is I'll rationalize only this part. Okay, this one obviously we'll leave it as it is. So rationalize only this. So how do we do that? See, we have 1 minus this will be what? Cos square A divided by 1 plus sine A. Now this, if you rationalize, you have to multiply with 1 minus sine A into 1 minus sine A. So try doing this. Let me try what Raghav said by the time. What Raghav said is actually easier. Nah, sometimes. You should take everyone's opinion. Okay, even if it is Raghav. See, so we took the LCM here. So if you took the LCM, you get this. Do you agree? Right? Now you see 1 minus cos square is sine square. So 1 minus cos square is sine square and then plus sine A. Then from these two you can take sine A common and then you end up with sine A plus 1. Sine A plus 1 that gets cancelled and you end up with sine A. Okay? You can do it like this also. So this is, I'll just name this Raghav's method. Okay? Have you changed your name so far? No, no? It's still Raghav, no? Okay. Maybe OG Raghav. How many steps for this one? 4. She finished in 4 steps.
So including the answer and the initial part.
Everything, everything.
Everything is 7.
So 3 steps. So after that, 3.
After that, 3. So 4. How? Okay, let's see. So we have 1 minus 1 plus sine, 1 minus sine will be 1 minus sine square A divided by cos square A into 1 minus sine A.
You can change the one side sine square A to cos A.
Yeah, so cos square A. Yeah, okay. You took it personally or cos square gets cancelled. Then 1 minus 1 plus sine A. So 1 minus 1 will get cut, you get sine A. So 1, 2, 3, 4 steps, including this 5. Raghav's method, this is 1, no, that's the question. That will be 1, 2, 3, 4. What should we do here? Yes, we can take LCM because you can see that this term and this term are similar. So let's start with taking the LCM. So the LCM will be what? It will be cosec A minus cot A times cosec A plus cot A. Okay, so if you remember, how do we do? This divided by this, whatever we get, multiplied by this. So here we have 1 plus sine A. So this whole thing divided by this. So cosec minus cot into cosec plus cot. If you divide by cosec minus cot, obviously cosec minus cot and cosec minus cot will get cancelled and you'll be left with cosec plus cot. So we have cosec A plus cot A. Similarly here we have 1 minus sine A into this divided by this. So I'll give you cosec minus cot. So I'll give you cosec A minus cot A. See, till here also it's not that easy. Till here everyone got it. You got?
One second, explain again.
How did I get this line? Okay, see. See again basics of your LCM, right? If you have A divided by B plus or minus C divided by D. So these are variables. For the variables, the LCM will be the product of the two. So it will be B into D. Okay. Now, B into D divided by B will be how much?
What?
B into D divided by B will be A. Very good.
Oh, sorry, AD.
It will be D. It will be D and that multiplied by A will be A into D. Similarly, BD divided by D will be how much?
B.
B into C will give you CB. You got it? Okay. There's a shortcut also to remember. You can just memorize it like this, but it doesn't work for all of them. D will be multiplied with A and B will be multiplied with C. So here also you can see this whole thing is being multiplied by this and this whole thing is being multiplied with this. See, this into this. So 1 plus sine cosec plus cot. This into this. 1 minus sine cosec minus cot. You got it? Huh? Okay. The numerator is going to be very long. Okay, so when you write, make sure that you have space. So we will multiply all of them. So 1 into cosec into cot will give you cosec A plus cot A. Then sine into cosec will get sine A into cosec A. Then sine into cot. So we get sine A into cot A. Then minus. So 1 into cosec will give you cosec A. Then 1 into cot A minus plus. So it will be plus cot A. Then minus sine into cosec. So plus sine A cosec A. And then minus plus and this minus will make it minus sine A cot A divided by cosec minus cot, cosec plus cot. So that will give you cosec square A minus cot square A. Numerator, does anything get cancelled? What can we cancel in the numerator? Sine A cot A and sine A cot A. Yes, we can cut this sine A cot A, sine A cot A. Then what else can we cut? Where is sine and cosec?
So cosec A and cosec A.
Yeah, we can cut plus cosec and minus cosec. What do you say? Can we cancel anything else? Huh?
No.
Yes, we can do that. We can take reciprocal of this and then this will also get cancelled, right? So what do we have? What can we add? Cot plus cot A plus cot A will be 2 cot A. And then that's it. So this one will do what Ananya said. Sine A into 1 upon sine A. Similarly, that will also be the same. So 2 into sine A upon sine A. And what is cosec square minus cot square? Check your formula. So then it'll be 1, then 2 plus cot A. So we can take 2 common and we get cot A plus 1. See, it's very lengthy, but it's very simple. Alright. So just scan through this and let me know if you don't understand any line. Yes. This one.
So
This one. This one we just multiply, Raghav. So you see 1 into cosec. So it'll be cosec. Then 1 into cot. So it'll be cot. And then we continue multiplying. Okay.